Text on Test 5, page 78, question 14. Use the mid-interval values to find the mean and standard deviation of the given grouped frequency distribution. To find the mean of the grouped frequency distribution, we use the formula: the mean is equal to the sum of the frequency multiplied by the variable divided by the sum of the frequencies. Rewrite the frequency distribution table in your books and add in an extra row for mid-interval and add an extra row at the end called f multiplied by x. So the variable as given in the question was 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, and the frequencies were 2, 3, 9, 7 and 3. I added in this extra row called mid-interval, and this is going to be our x, our variable, and our frequency is going to be our f, and our frequency multiplied by our variable. So the mid-interval value between 0 and 4 is 2. The mid-interval value of 4 and 8 is 6. The mid-interval value of 8 to 12 is 10. 12 to 16 is 14. 16 to 20 is 18. So these now are going to be our x, or our variables. What we need to calculate next is the frequency multiplied by the variables. So 2 by 2 is 4, 6 by 3 is 18, 10 by 9 is 90, 14 by 7 is 98, 18 by 3 is 54. Once we've done that, calculate the sum of the frequency. So 2 plus 3 plus 9 plus 7 plus 3 is 24. And next we calculate the sum of the frequencies multiplied by the variables. So that's 4 plus 18 plus 90 plus 98 plus 54 gives us a total of 264. So back to our formula, the mean is equal to the sum of each of the frequencies multiplied by the variable, which is 264, divided by the sum of the frequencies, which is 24. So the mean is equal to 11. In the second part of this question, we need to calculate the standard deviation. So start creating your table. Your headings for the table are going to be variable, frequency, variable minus mean squared, frequency multiplied by the variable minus the mean squared. So our first ones, our variable is 2, our frequency is 2, our variable 2 minus our mean 11 is minus 9, our variable minus mean squared is 81, our variable minus the mean squared multiplied by the frequency is 162. A variable of 6 and a frequency of 3. Our variable minus our mean is minus 5. Our variable minus our mean squared is 25. Our variable minus our mean squared multiplied by our frequency is 75. A variable of 10 and a frequency of 9. Our variable minus our mean is minus 1. Our variable minus our mean squared is 1. Our variable minus our mean squared multiplied by the frequency equals 9. The variable of 14 and a frequency of 7. Our variable minus our mean equals 3. Our variable minus our mean squared equals 9. Our variable minus our mean squared multiplied by the frequency is equal to 63. So we have a variable of 18 and a frequency of 3. Our variable minus our mean gives us 7. Our variable minus our mean squared is 49. Our variable minus our mean squared multiplied by our frequency is 147. We need the sum of the frequency column. So the sum of the frequencies is equal to 24. So that's 3 plus 7 plus 9 plus 3 plus 2 gives us 24. And then we need to find the sum of the last column, the frequency multiplied by the variable minus the mean squared. 162 plus 75 plus 9 plus 63 plus 147 gives us 456. So now moving on to our standard deviation formula. Our standard deviation is equal to the square root of the sum of all the frequencies multiplied by the variable minus the mean squared divided by the sum of the frequencies. We found the sum of the frequencies to be equal to 24, and the sum of all the frequencies multiplied by the variable minus the mean squared to be equal to 456. Putting them into our formula, we get the square root of 456 over 24, so our standard deviation is equal to 4.36.